What are enantiomers? Enantiomers are molecules that have the same molecular formula that are not superimposable with each other and are mirror images. A molecule must be chiral to be considered an enantiomer. A chiral molecule contains one asymmetric center. All four groups attached to this asymmetric center must be different. For example, here is a molecule containing carbon as the central atom. It has four different groups attached to it. The first group is an alcohol group. The second group is a chloral group. The third group is a hydrogen atom. And the fourth group is a methyl group. A simple example of enantiomers can be a right and left hand. Each hand contains a palm and 5 fingers. Each finger has a corresponding finger on the other hand. Even though both hands have the same components, they are not identical. As you can see here, if you overlap your right and left hand, they do not line up perfectly. You can also rotate one of your hands around and you will see that it will never line up with the other hand. A chemical example of enantiomers is lactic acid. Lactic acid enantiomers both have the same molecular formula, C3H6O3. The enantiomers are mirror images of each other and thus have a different 3D representation in space. As you can see by the drawings of the enantiomers, they are exactly opposite of each other. Their different representation leads to a different reactivity within biological systems. The L-lactic acid enantiomer is found in muscle tissue, while the D-lactic acid enantiomer is found in sour milk. So why are enantiomers important? As you can see with the lactic acid example, different enantiomers have different effects. This is because biological systems have receptors. Receptors are very specific and bind to different proteins and produce different effects within the body. The yellow rectangles each represent the same binding site. The binding site has very specific orientation. A molecule that is going to fit into the binding site has to fit it perfectly. There are two enantiomers that are trying to fit into this binding site. The enantiomer on the left fits into the binding site and is the active enantiomer. This is because it lines up perfectly. The circle goes with the circle, the triangle goes with the triangle, and the L-shaped atom goes into the L-shaped receptor. The enantiomer on the right does not fit into the binding site and is an inactive enantiomer. This means that it will not have an effect in the body. The L-shaped atom is trying to line up with the circle receptor. The circle-shaped atom is trying to line up with the L-shaped receptor. Even if you rotate this molecule around, it will never fit into the receptor. An example of enantiomers is the drug thalidomide. Thalidomide was a drug taken by women from 1957 to 1961 that relieved morning sickness during pregnancy. However, it turns out that thalidomide also caused severe birth defects. You can see on this page the enantiomers of thalidomide. It was originally thought that the R enantiomer of thalidomide was the sedative, and the S enantiomer of thalidomide caused the birth defects. Thalidomide was taken as a racemic mixture, meaning that both enantiomers were present in equal amounts. The S-thalidomide would bind to a biological receptor sometime during fetal development and would cause malformations of the limbs. It turns out that the R-thalidomide can be converted by the body into the S form. This is an example of racemization, or converting one enantiomer into the other. A final relevant example of enantiomers is ascorbic acid. Ascorbic acid has a molecular formula of C6H8O6. The L enantiomer of ascorbic acid is more commonly known as vitamin C. You can see the drawings of both enantiomers on this page. Even though both enantiomers have the exact same molecular formula, the D enantiomer of ascorbic acid has no physiological significance, and the L enantiomer of ascorbic acid is an essential nutrient in the body. Vitamin C has also been known for hundreds of years to prevent certain diseases like scurvy. Some evidence also shows that an increased vitamin C intake can ward off certain colds and illnesses.